A very good day to everyone. My name is Lushini, and today I'll be presenting my scientific poster entitled Green Coagulation, Eco-Friendly Treatment of Melting Plant Effluent Using Plant-Based Coagulant. This study focuses on the use of plant-based biocoagulants such as aloe vera, cactus opuntia, and okra seeds in treating brewery melting wastewater, and compares their performance with alum, which is a conventional chemical coagulant. First, for the introduction, brewery and malting industries produce larger amount of wastewater containing suspended solids, dissolved solids, and organic pollutants. If this wastewater is discharged without proper treatment, it can negatively affect the water quality and aquatic ecosystem. One common treatment method is the coagulation and flocculation process, where particles in wastewater are destabilized and removed. Traditionally, industries use chemical coagulants such as alum because they are effective. However, alum has several disadvantages. It can increase treatment costs, change water chemistry, and produce chemical sludge, which may create environmental concerns. Because of these limitations, researchers are looking for more sustainable alternatives. Plant-based biocoagulants are promising because they are biodegradable, renewable, low cost, and environmentally friendly. In this study, the selected biocoagulants were aloe vera, cactus opuntia, and okra seeds, as the plant contains natural compounds such as polysaccharides, proteins, and functional groups that helps to destabilize suspended particles and promote formation. So, this study was carried out to evaluate whether these plant-based materials can effectively treat brewery wastewater and potentially replace or reduce the use of chemical coagulants such as alum. Next, the objective of this study are to evaluate the effectiveness of aloe vera, cactus opuntia, and okra seeds as natural biocoagulants for the treatment of brewery malting wastewater. And the second objective is to determine the optimum dosage and best blending ratio of these biocoagulants for maximum removal of turbidity and total dissolved solid. Next, moving on to the methods. The methodology can be divided into 5 main steps. Step 1 is the sample collection, where first the brewery melting wastewater was collected from a processing plant in Bulawayo, Zimbabwe. The wastewater was then characterized based on parameters such as turbidity, pH, TDS, and also conductivity. For step number 2 is the biocoagulant preparation, where the selected plant materials, which were okra seeds, aloe vera, and cactus opuntia leaves, were washed, dried, ground, and sieved into powder form so that they could be used as coagulants. Step number 3 is the experimental design, where a simplex centroid design was used to prepare both individual biocoagulants and blended biocoagulants at different mixing ratios. Step number 4 is the jar test procedure, where the coagulation performance was then tested using the jar test method. Different dosages of coagulants, which were 30, 35, 40, 45, 50, and 55 milligram per liter, were added into the wastewater. The samples were mixed rapidly at 200 rpm for 2 minutes, followed by slow mixing at 30 rpm for 10 minutes, and then allowed for settlement for 30 minutes. Finally, after treatment, water quality parameters such as turbidity and TDS were measured, and the removal efficiency was calculated using formula. Now, I will move to the results, which are divided into turbidity removal and TDS removal. First, let's look at figure 1, which shows the turbidity removal efficiency at optimum dosages. The initial turbidity of wastewater was 734 NTU for all treatments. Among all coagulants tested, alum showed the highest turbidity removal, reducing turbidity from 734 NTU to 68 NTU at a dosage of 40 mg per liter, which corresponds to 90.69% of removal efficiency. Among the plant-based biocoagulants, okra seeds performed the best. At an optimum dosage of 95 mg per liter, the final turbidity decreased to 82 NTU, giving a removal efficiency of 88.83%. For the biocoagulant blend, the optimum ratio was 0.17 for aloe vera, 0.17 for cactus, and 0.67 for okra seeds, at a dosage of 40 mg per liter. This blend reduces turbidity to 118 NTU with a removal efficiency of 83.92%. In comparison, aloe vera and cactus opuntia showed lower turbidity removal efficiencies of 74.25% and 74.66% respectively. Next, for figure 2, presents the TDS removal efficiency at optimum dosages. The initial TDS of wastewater was 90,800 ppm for all treatment. Again, alum recorded the highest TDS removal, reducing TDS from 19,800 ppm to 880 ppm at 40 mg per liter, which corresponds to 95.56% of removal. However, all plant-based coagulants showed very high TDS removal, all above 95%. Aloe vera reduced TDS to 910 ppm with 95.40% of removal. Okra seeds reduced TDS to 940 ppm with 95.25% of removal. Cactus opuntia reduced TDS to 990 ppm with 95 50% of removal. And the biocoagulant blend reduced TDS to 935 ppm, giving 95.28% removal. This shows that although alum remained the best overall, the biocoagulants achieved very comparable TDS removal performance. Now, moving to the discussion part. The first important finding is that okra seeds were most effective biocoagulant, especially for turbidity removal. This is likely because okra seeds contain natural polymers and functional group that improve particle destabilization and flock formation, making them highly efficient in removing suspended solid. Secondly, alum still showed the highest overall performance, especially for turbidity. However, one limitation of alum is that it can cause a greater reduction in pH, which may require additional pH adjustment before wastewater discharge. Another important result is the performance of the biocoagulant blend. The blend performed better than aloe vera and Coptis aurantia individually, which suggests a synergistic effect when different plant materials are combined. In other words, combining the biocoagulants improved treatment efficiency compared to using some of them alone. In addition, one treatment achieved high TDS removal above 95%, showing that plant-based coagulants are also highly effective in reducing dissolved contaminants. Overall, this finding shows that plant-based coagulants have strong potential as sustainable and eco-friendly alternatives to conventional chemical coagulants in industrial wastewater treatment. Lastly, for summary, this study successfully evaluated the use of aloe vera, Cactus aurantia, and okra seeds for treatment of brewery melting wastewater. Among the biocoagulants, okra seeds were identified as the best individual coagulant, achieving 88.83% of turbidity removal and 95.25% of TDS removal. The optimum biocoagulant blend, which consisted of 0.17 for aloe vera, 0.17 for Cactus aurantia, and 0.67 for okra seeds, achieved 83.92% of turbidity removal and 95.28% of TDS removal at 40 mg per liter. Although alum still showed the highest overall performance, the plant-based coagulants produced comparable treatment efficiencies, especially for TDS removal. Therefore, this study concludes that plant-based biocoagulants are promising, sustainable, and cost-effective alternatives for industrial wastewater treatment, particularly in reducing dependence of chemical coagulants. Finally, these are the references that had been used in this study. Lastly, I would like to acknowledge the institutions and researchers involved in this study, especially the Botswana International University of Science and Technology, the National University of Science and Technology in Zimbabwe, and the University of Witwatersrand, South Africa, for their support and contribution to this research. That is all from me. Thank you.